Maths and Architecture by Khushi, 10th A. Mathematics and Architecture. Geometry, algebra, and trigonometry all play a crucial role in architectural design. Architects apply these math forms to plan their blueprints or initial sketch designs. They also calculate the probability of issues the construction team could run into as they bring the design vision to life in 3 dimensions. Pyramids and temples are some of the earliest examples of mathematical principles used in architecture. Today, mathematics continues to feature prominently in building designs. Architects use geometry to define the spatial form of the building. So the question arises, what type of maths is used in architecture, and can one be an architect without being good at math? Algebra, geometry, and trigonometry are prerequisites for taking calculus, and calculus is required to complete a degree program in architecture. Some students complete the algebra, geometry, and trigonometry requirements in high school and can immediately start with calculus courses in college. Basic maths is helpful for sure, but good at maths can't make you an architect. One's math ability should never be the factor that keeps them out of architecture. However, one needs to be adept at math, namely algebra, geometry, and trigonometry, to deal with the array of dimensions, quantities, area, volume, and other geometric relationships. This plays into spatial thinking and patterns. The higher, more complex area of math, such as calculus, hinder many students. But it is the logic pattern of math, such as this, that is a critical tool in the mind of an architect. So now, we are going to take a look at several structures that were modeled after mathematics. On number 1, we have Magic Square Cathedral. The Sagrada Familia Cathedral in Barcelona, designed by Antoni Gaudi, is a mathematician's dream. Hyperbolic paraboloid structures are featured throughout. Have you eaten Pringles? Then you definitely know what a hyperbolic paraboloid structure is. Catenary arches abound. The cathedral also contains a magic square, an arrangement of numbers that equal the same amount in every column, row, and diagonal. The magic number in Sagrada Familia's case is 33, which alludes to multiple religious symbols. For example, Jesus performed 33 recorded miracles, and most Christians believe he was crucified at 33 years old in 33 AD. Next, we have mathematically inclined cucumber in the sky. Standing 591 feet tall with 41 floors in London's skyscraper known as the Gherkin. Yes, like the cucumber. The modern tower was carefully constructed with the help of parametric modeling, amongst other math-savvy formulas, so the architects could predict how to minimize whirlwinds around its base. The design's tapered top and bulging center maximize ventilation. The building uses half the energy of other towers the same size. Any mathematician would be pleased to claim credit for the building, but architectural firm Foster and Partners might have something to say about that. Next, we have Experimental Math Music Pavilion. Imagine walking up to the Philips Pavilion at the 1958 World's Fair and seeing this crazy construction of asymmetric hyperbolic paraboloids and steel tension cables. Mind blown. This amazing building appeared at the first expo after World War II. So it was an important moment that allowed its creator to show off the technological progress the world had made since the devastating battle. Philips Electronics company wanted to create a unique experience for visitors, so they collaborated with an international group of renowned architects, artists, and composers to create the experimental space. Arc Daily wrote about the groundbreaking temporary building calling it the first electronic spatial environment to combine architecture, film, light, and music to a total experience made to function in time and space. It was through these visually inspired concepts that elevated the Philips Pavilion into a complete experience where one could visualize their special moments through a space of sound, light, and time. And now, at last, we have the Great Pyramid of Giza. The Great Pyramid of Giza is situated in Cairo, Egypt. The ratio of the height to the base is 0.636. The Great Pyramid has a base of 230.4 meters, which is equal to 755.9 feet, and an estimated original height of 146.5 meters, which is equal to 480.6 feet. The surface area of the base is 2 into 2 or 4. So 4 sides is 4 multiplied by 5 divided by 4 or 5 for the ratio of sides to base. Now, we have some amazing facts about the Great Pyramid of Giza. The superlatives that describe the Great Pyramid of Giza speaks for itself. It's the largest and oldest of the 3 pyramids and was the tallest man-made structure in the world for 3,800 years. But there's also plenty of math behind one of the 7 wonders of the ancient world. Did you know that in cubits, the pyramid's perimeter is 365.24 meter, the number of days in the year? That the pyramid's perimeter divided by twice its height is equal to pi? Or that the king's chamber measurements are based on a Pythagorean triangle? No, you didn't know, but now you do. So, this was all it. Thank you. I hope you liked it.